Okay, so now we're on the second question of Jim Coroneos' list of 100 integrals, right? And the integral we've been given, right? I've named it I. I equals to the integral of x all over x, the square root of x squared plus 4 integrated with respect to x. Okay, now this integral might seem pretty similar to the first one. You might be mistaken, to think that this solving the integral would result in a log answer, natural log answer. But of course, it's not that, because what makes a difference is the actual square root. So the way we actually solve this integral is by our standard u-substitution. Okay, so how do we do that? We can see that the denominator has x squared plus 4, right? And the numerator is a lot simpler. It's just x, and we notice that if we take the derivative of whatever's inside the square root, which is x squared plus 4, the derivative of that will be 2x. We have an x on the top, right? And all we really need to do is to really multiply 2 to the denominator and place a half there. That's the shortcut way, but we can do this using formal u-substitution, right? So we can do that. Let's let u, right, be x squared plus 4, right? And we take the derivative, so the derivative of u with respect to x will become 2x, right? And if we treat the differential dx as simply a number, we can multiply dx to both sides. So du equals 2 times x multiplied by the differential dx. Now, as we can see on the numerator, dx, right, like it's really beside the fraction, but it's being multiplied, so the differential dx right here, right, would actually be up here, right? And you can see that we have almost the same thing on here, except we've got a 2 at the front. So what we do is, in here, right, we have du, the differential du equals 2 times x multiplied by the differential dx. We're going to divide by 2 on both sides. So what we get is we get du, right, hold on, we get du on 2 equals x multiplied by dx. And this, right, is on the numerator in the question, right? So we can substitute x dx with du on 2. And whatever's inside the radical, which is x squared plus 4, we can replace that by u, because that's what we introduced in the first place. So what we can do is this I equals to x times dx, which we substitute with du on 2, right? And this is over the square root of the quantity x squared plus 4, which we made as equal to u, right? Now, actually, let me rewrite the numerator in a different way. I know it's du on 2, but that's really the same thing as saying half of du, right? Half times du. It might seem intuitive, but it might catch you off guard, like, oh, well, how do we deal with the half, right? And half is a constant, so of course we can take the half outside the integral. So we have half times the integral of du on the square root of u, but I'll rewrite the square root of u as u to the half, right? That's an equivalent statement, so we have u to the half. But of course, when we have 1 over u to the half, right, that's exactly equivalent to saying u to the power of negative a half, recalling our indices rules, right? So this would be equal to half times the integral of u to the power of negative a half integrated with respect to u, right? And now, really, it's just a simple integral that we can solve, right? So it's going to be half times, and I'm just going to put the brackets to signify a multiplication operation. We raise the power by 1, so negative half plus 1 is positive half. And then we're going to divide that by half as well, right? And of course, we're going to add the c at the end, which is a constant of integration. And any quantity divided by half is really the same as 2 times the quantity that's on the numerator, right? And we have half times 2, so that goes away. That becomes a 1, but I treat it as an elimination, and what we get is u to the half plus c. But of course, we know that u, right, we've introduced u as x squared plus 4. So that means that we substitute back our original substitution for u, which is x squared plus 4, and we get x squared plus 4 to the power of a half plus c. And we can leave that as our final answer, but we know that anything to the power of half is really a square root. So this will be the square root of x squared plus 4, or plus c. And yeah, that's the answer to the second question.